Good morning, dear students. Today we are going to discuss about the water lesson. In the 8th standard chemistry, unit number 13, you have a water lesson. நீரின்று அமையாது உலகு. That is a Quran saying that without water nothing is there. We cannot survive, whether animals or plants. Nothing can survive. Nothing can be produced without water. So water is such an essential thing which we need to have each and everyone in day-to-day life. Okay. Without water, the life of animals or plants, nothing will be available. And nowadays we are have a demand of water. Water is a very demanding one, and also we are in the position to protect, save the conserve the water sources, and we should keep that. So that much knowledge about the water we should know. The chemical knowledge regarding the chemical knowledge about the water, that is we have this lesson, water lesson. What is the composition of water? First of all, we are going to see the composition of water. See, water contains hydrogen and oxygen. That you know very well. Hydrogen and oxygen are water composition. In ozone, natural occurring, 97.25% of water occurs in ozone. Then 2.05% that is in polar ice caps and glaciers. So these two will not be used. Okay, you cannot use. It is in ozone and this is in polar regions. Okay, so remaining very less amount, closely 0.45% of water only we are having in all the sources, in well, lake and rivers, everything we are using. Now only 0.5% of water only we are using. Okay, that are we are in the position to conserve the water first of all. Then water, the chemical name of water is dihydrogen monoxide. Dihydrogen monoxide. That's why we are writing the formula H2O. Dihydrogen monoxide. Okay. Then when it is supplied to the current, it is cleaving into the hydrogen and oxygen. That process is called electrolysis. By applying current, we are cleaving the water into hydrogen and oxygen. That is called, that process is called electrolysis of water. Electrolysis of water, that we are going to see how the electrolysis process can carried out. If you take the beaker, it is full of acidified water. This is full of acidified water. Okay, that is called electrolyte. Then there will be two rods, two carbon rods we need to locate. These two carbon rods are called electrodes, which is connected to the positive terminal of the battery. The electrode, the rod which is connected to the positive terminal of the battery is called anode, which is connected to the negative terminal of the battery is called cathode. Okay, then you cover with a test tube in both sides. Okay, the acidified water, when you apply the current, what happens? Hydrogen and oxygen are splitting into that. This side, the gas is evolved. It is covered by the test tube, that is called oxygen. It is deposited at a anode. Likewise, in this side, cathode, you will have a hydrogen. How do you know, sir? This is oxygen, that will be hydrogen. You have to the experiment to do that. The experiment for the oxygen, if you go the matchstick close to that, it will be glow it will burn brightly. It shows that it is a supporter of combustion. So the gas must present in this side, it will be oxygen. Then if you bring the same that to this side, you have pop sound. Pop sound mean for the hydrogen. It will pop sound. You can have that the sound you can hear. It shows that it is the hydrogen. The chemical reaction, if you want to have what is the electrolysis process, while undergoing the water, undergoing the electrolysis, you are getting 2 times of hydrogen and 1 times of oxygen. That means the 2 volumes of hydrogens are consumed here, then 1 volume of oxygen consumed here. That's why the ratio is 2:1. 2:1. That's why the name is dihydrogen monoxide. For if you assume that 2 volumes of hydrogen is consumed at a time, the same time you will have 1 volume of oxygen. Or if you 10 volumes of hydrogen you consume during the electrolysis, you will have 5 volumes of oxygen. That is called 2:1 ratio, hydrogen and oxygen ratio. Then let us move on to the preparation. It is clear that electrolysis is clear. Then let us move on to the preparation of water. Water first of all prepared and which is prepared from the treating the metal with strong acids. Like zinc is taking zinc. Zinc is treated with sulfuric acid. As a result, you are getting zinc sulfide and hydrogen gas is evolved. This hydrogen gas is very composed with air to form a water. This is the reaction you are having. Hydrogen is treated with oxygen to give a water, 2H2O. Then sometimes you can get a water while you bursting the hydrocarbons like a glucose. What is the formula for glucose? C6H12O6. Then 6 times of oxygen, you get 6 times of carbon dioxide and 6 times of water plus energy. While you composing the hydrocarbons also, you can prepare water. These are a generalized method to prepare. What is the laboratory preparation of water? That we need to know. Laboratory preparation. In laboratory preparation, the pure hydrogen gas, the apparatus will be like this. The pure hydrogen gas is applied to that apparatus. Here you will have an anhydrous calcium chloride. What is the role of calcium chloride here? The calcium chloride will absorb the moisture from the hydrogen. So you will have a dry H2. Dry hydrogen gas will be there. It will be going out. It will be composed. This passed through the apparatus like this. Here you will have a cold water inlet. The ice water will be supplying to inside. That is called the inlet. Because when the hot air, dry hydrogen gas is bombarded here, you will have water droplets you collecting. This is a distilled water. This is called a distilled water. Pure distilled. Nothing is there. This is called a distilled water. Distilled H2O you are assuming here. Then the hot water will go away. You can receive the hot water this side. The cold water inlet is nothing but a cold water always being here, and continuous supplying of cold water will be there. When the dry gas is bombard the outside the container, it will be cooled. When it is cooled, water droplets will come out because the air having oxygen, hydrogen and oxygen combined to form water droplets you can collect here. The system will go on. Okay, this is called laboratory preparation of water. Okay, this is called laboratory preparation. The general method of preparation that this is a laboratory preparation. Then let us move on to the physical property. Physical property. Then let us move on to the physical property of water. In nature, what is the nature? It is clear, transparent liquid. What is a clear, transparent liquid? Colorless, odorless, tasteless. Nothing is there. It is a clear, transparent liquid, colorless, odorless, tasteless. Then let us move on to the boiling point. What is boiling point of water? Boiling point of water, as you know very well, it is 100 degrees Celsius, it starts boiling. Okay, at 100 degrees Celsius, it starts boiling. Water getting boiling. Then, what is the effect of pressure while boiling? When the pressure increases, when you apply the pressure increases, boiling point also increases. Pressure increases, boiling point also increases. Then let us move on to the freezing point of water. Freezing point of water is nothing but you know very well, that is 0 degrees Celsius. At a 0 degrees Celsius, water starts freezes. Okay. What about the pressure effect there? When the pressure increases, freezing point decreases. See, it is a controversial to that. Boiling point increases with increase in pressure, whereas a freezing point decreases with a increase in pressure. Then density. Regarding the density of water, it is heavier than that of the ice. No, that's why the ice cubes are floating in the water. If you keep the ice cubes in the beaker with water, the ice cubes will be floating on the water because the density, comparatively density of ice, both are having the molecules H2 only, but density of the ice is less than that of the water. At 0 degrees Celsius, what is the density of ice? 0.09 gram per cubic centimeter, that is ice. At a 0 degrees Celsius, the density of water is 0.97. Say here 0.06 times increases, 0.91, that is density of ice, whereas the density of water is 0.97 gram per H2O. Okay. Then at 4 degrees Celsius only, the density of water is 1 gram per cubic centimeter at 4 degrees Celsius. When this is an important neat question also, it is a very important question. When the density of water is 1 gram per cubic centimeter, that is at 4 degrees Celsius. Always you don't have a 0 degree. 0 degree, it is less than 1 gram per cubic centimeter. Whereas at 4 degrees Celsius, water will have a density as 1 gram per cubic centimeter. Then more than 4 degrees Celsius, it is greater than, it will be more than that. Okay, then anomalous expansion. This is an important physical property of water. See, the comparing the volume for ice and water, the volume occupied by the ice will be more than that of the water. Okay, volume occupied by the ice. Volume of ice is more than that of the volume of water. That's why in winter season, in Himalayan region, the water getting start freezing. That time the pipe or a connection is not good, the cracks will be available. Okay, that ice will water. Then latent heat of fusion. What is called latent heat of fusion is nothing but when it is fused, the ice cube at 0 degrees Celsius, there is no rise or fall in temperature. Okay, the solid ice, if we keep a thermometer there is no rise or fall in a temperature for some times. Why? Because that there will be some changes. No, that the energy is used to convert the solid ice to the liquid. That energy, the amount energy is required to convert the solid ice to the liquid, that is called heat of fusion, latent heat of fusion. That value is 80 calories per gram, or in joule per gram 336 joule per gram. Then latent heat of vaporization. The same way, at 100 degrees Celsius, water getting vapor, the liquid will become a gaseous. At 100 degrees Celsius, if you keep the thermometer there, for some time there will not be change in the temperature change. That is because the amount of energy utilized to convert the liquid into gas, that is called latent heat of vaporization of water. That value 540 calories per gram, or 2268 joule per gram. Okay, that is a latent heat of vaporization of water. Then specific heat capacity. Specific heat capacity is nothing but 1 degree rises the amount of heat energy required to rise the substance from the normal degree to 1 degree rises. For example, 10 degrees Celsius to 11 degrees Celsius, to change that temperature range, the degree of the temperature changed by 1 degree, that is called a specific heat capacity. For water, specific heat capacity is more. 1 gram, that is equal to 1 calories. 1 calorie. 1 gram equal to 1 calorie. That's why it is used as a coolant in a motor engine. If you see, it is used as a coolant. That is a 1 gram, that is equal to 1 calorie. Then let us move on to the chemical properties of water. Chemical properties of water. Accent towards the litmus paper. Water, it is neutral to the litmus paper. See, litmus, when you use the litmus paper, blue litmus convert to red, that is called acid. When red litmus convert to blue, that is called the base. In sometimes there is no change in the litmus paper, that is called neutral. So if you test the litmus paper with water, it shows that neutral towards the litmus paper. There is no change in the litmus color. So that is called neutral litmus paper. Then stability. What is the most stable compound, as you know very well. It is cannot easily decomposed. When it is heated 2000 2000 degrees Celsius. In a book 200 they will be given in the arrow mark. If you see the 2000 will be changes, you made the correction. At 2000 degrees Celsius, you will have a after 2000 degrees Celsius, if you heat it, you will get a 0.02% only. It will be decomposed. Hydrogen and oxygen, you can get it. So it shows that it is such a most stable compound. Then catalytic nature. What is the best catalyst? Common catalyst used in a more reaction. For example, chlorine and hydrogen, they do not react easily. Hydrogen and chlorine, they will not react easily, straightly. When it is used in the moisture at sunlight, you can get the 2HCl. Okay, the reaction carried out only in the presence of moisture. Moisture is water. Then reaction with metals. Different type of reactions are there within a metal. For example, sodium, potassium, calcium. They are treating vigorously at room temperature with water. Sodium, potassium, calcium. They are reacting very vigorously with at room temperature itself. Whereas for the example, sodium and water, you can get sodium hydroxide and hydrogen gas is liberated. Okay. Then the magnesium will not react with room temperature, but at hot water, the temperature is increases. At hot water, magnesium can react to give magnesium hydroxide and hydrogen gas. Whereas copper, like a few metals, do not react with water. There is no reaction with water. That's why copper is used in many things. Okay, copper do not react with the water. Then reaction with non-metal. That final chemical properties of water is reaction with non-metal. Carbon and water to give a carbon monoxide and hydrogen at 1000 degrees Celsius. Carbon is a non-metal. Non-metal treated with the water at 1000 degrees Celsius. Okay, carbon plus water at 1000 degrees Celsius. You are getting that carbon monoxide plus hydrogen. Okay. Then likewise, chlorine and water to react at sunlight. In the presence of sunlight, hydrochloric acid is produced and oxygen is produced. Okay. These are the reactions non-metal. So far we have discussed about the chemical properties of water. What are the action towards the litmus paper? Stability, catalytic nature, reaction with metal and reaction with non-metal. Okay.